Okay, these we didn't have time, so I'm going to finish up with these. Okay, what if I give you the graph and I want you to come up with a polynomial function? All right, so if this is my polynomial function, let's think of all the things we have to consider. Okay, let's look at end behavior. This is kind of bunny ears down, right? They're kind of going off to infinity this way. So it's, similar to a parabola, right? As far as end behavior goes. So we know the overall power has to be even, but we also know it has to be negative because it's reflected. Okay, so I know that whatever is the coefficient here, I don't know what it is, but I do know that A is going to end up being negative when I solve for it. All right, so let's start. It's always a good idea to start with the factors. So what are they? -1, -2, -3. And again, remember the shift is always backwards of what the x's are. -1, so that would be +1. +1 would be -1. And I'm running out of space. Was it 2? That'd be x minus 2. Okay, so that's the first step. So I have 4 x-intercepts. I have 4 factors. All right. Now, do they go through or do they touch? So this one goes through, and through. So those need to be odd powers. Okay, now I'm going to make them all 1. I could make them all 3s. I could do 5s. I could do a 7, a 5, and a 3. I could do a 3, a 1, and a 21. Doesn't matter. Okay, but we're going to solve for A. And because of that, I don't want huge exponents unless I need them for the changes in direction. All right, let's look at what is happening at 2. Are they all going through? Oh my gosh, Julie. 1 going through, 2, 3. Okay, they're all going through. Sorry, I thought I had a touch there, but I don't. Now, let's check to see if this is okay. Because the overall power, let's see, is even. So 1, 2, 3, 4. My exponents would be x to the 4th power. So it would behave similarly to x to the 4th, which again would give that behavior if it's reflected. Now, let's look at the number of humps. 1, 2, 3. Okay, so if the overall power is 4, 4 minus 1 would be 3 changes in direction. And so I'm okay because this guy has 3. All right, so we're all good there. All right, so technically these could be any odd numbers, but the problem is I want to solve for A, and so I don't want them to be any odd. I'm going to go with the first power to make life easy. Okay, notice I give you an input and output. Anytime someone gives you an input and output, you sub it in, right? That's what we do. And if you're like, well, how do I know what A is? Well, you know what your input is. You know what your output is. The only thing you don't know is A. So you can figure it out, okay? And this is a common thing in algebra is subbing in inputs and outputs. And then there's one thing you don't know and you can figure it out. Okay, my output is 9, right? This is your input, output. So X is your input, Y is your output. So let's see, input is 2. So that's going to be 5. And you can see why I picked to the first power so I don't have to do more work. Sub in 2, I get 3. Sub in 2, I get what? 2 minus 1 is 1. Sub in 2, I get 0. That's a problem. That is a problem. Okay, I'm going to make a quick video finishing up with polynomials. So there's a lot of things you have to think up with polynomials. So on a cheat sheet for the exam, you can have not an example, but of things to check. So here we have overall behavior. Notice it's, does some stuff in the middle, right? But it goes down. So it's kind of like bunny ears reflected. So it's kind of like x squared, x to the 4th, x. So we know it's going to have an even overall power, but we also know it's going to have a negative coefficient because it's been reflected. All right, so here we'll call this polynomial of x. We don't know what the coefficient is. I'm going to put a variable there, a. We do know that we have 1, 2, 3, 4 x-intercepts, so we have 4 factors, okay? This one goes through -1, -2, -3, so remember the shift is always opposite, -1, so that's x plus 1. This is at 1, it's x minus 1, and this is at 2, so that's x minus 2. All right, so we know that. All right, now we look, does it touch or go through? And it looks like all of these go through, which means these are all odd powers, okay? Now, I am going to put them all to the first power. which again, you wouldn't have to write. You could put them cubed, you could put fifth, you could put seventh, you don't know. But if we're trying to solve for A, we probably don't want higher math than, we want the easiest math as possible. All right. So right now, then after you do this, you have to go back and make sure it works, right? So this would be x to the fourth. So, all right, that's even, that's good. Now remember, if it's x to the fourth, we have n minus 1 changes of direction we have to check. 4 minus 1 is 3. Well, I have 1, 2, 3 changes in direction, so I'm okay. If I had more, kind of humps and, valleys and peaks, then I would need to change the power to like a cubic or fifth power or something, because I need more changes in direction. All right. So at this point, we've done all that, which is great. And you're like, but how do I know what A is? Well, in math, if someone gives you an input and an output and you have something you do not know, probably you should sub in that input and output and figure out what A is. So input is a -2. I don't know what A is. So a -2 plus 3 is 1. A -2 is a -1. -2 minus 1 is a -3. -2 minus that is -4. And then my output is my Y value. That's 9. Okay. So all I did is everywhere I saw an X, I just subbed in a -2 because that's your input. So that's what we do with functions all the time. So that's where my 1 came from, my -1, my -3, and my -4. So order of op, these are all multiplied. There's no adding or anything here. So what is that? That's a +12. That'd be a -12. And again, it's all multiplying here. Okay. There's no add or subtract. So to get rid of multiplying, again, to solve, you do the inverse. So isolate and inverse. So A is -9/12. Now I can simplify that by dividing both by 3. So A is what? -3, is that 4, hopefully? Okay, if I make a dumb mistake, you guys can email me and let me know. So now I know the coefficient. So now I can write the function, and it doesn't surprise me it's negative. If it's not negative, then I'm like, okay, Julie, I messed up. I did something wrong. Now, if you graph this, it's possible that what you come up with doesn't quite match your graph. Maybe a few more humps or something like that. That might be if you did some odd powers in here. But is the overall behavior okay, right? Like does it have x-intercepts here, or roots or solutions? Does it go off to negative infinity on both ends? Does it have the right number of changes in direction? Things like that. Okay, those are the biggies. All right, let's look at this middle one. All right, so here I am, giving you the graph. Now I am giving you some hints over here. So let's start with our polynomial function. What do we know? Well, we have 3 factors because we have 3 zeros. Okay, this is at 1, so the shift, so -1 would undo the shift. 1, 2, x minus 2, and 3, x minus 3. Let's see what's happening here. These two are going through, right? The graph is going through. So those are odd powers. And again, I'm going to stick with the lowest power possible if I can, right? I will up it if I have to. Now this one touches. So I'm going to go squared on that because even power. Okay, let's check the overall degree. They tell us it's 4. Okay, now we would know, see how it's kind of going off to bunny ears, right? Like it's similar to a parabola where it's going off, right? Not reflected though, it's not this one. So it could be 2, 4, 6, x to the 10th power, something like that, an even power. But they tell us degree 4. All right, so notice 1, 2, 3, 4. If we kind of ignore our numbers there, we'd have x squared, x, and x. That'd be x to 4. So I check mark on that. Changes in direction, I have 1, 2, 3. 4 minus 1 would be 3 changes in direction. So that's n minus 1 changes in direction. So I'm good there. All right, so the only thing I don't know is the coefficient, right? I know it's positive, but that's about all I know. So I'm given a point. Now, again, this is your input, this is output. So instead of giving you a point on the graph, I'm giving you input is 0, 36. It's off our graph, we can't see it. All right, and that would be, if I write it as an order pair, it would be this. That is our y-intercept, by the way. All right, so again, anytime someone gives you input and output, it's a good idea to put it in. So I'm going to sub in. So there's my output. My input is 0. So if I sub in 0, I get that. If I sub in 0, I get that. If I sub in 0, I get that. So 36 equals A. This is going to be what? Positive 6 times a positive 1. That's going to be 6. Again, there's no add or subtract on this guy. To isolate, I'm just going to divide. It looks like A is 6. So to write my polynomial function, I have 6, x minus 1 squared, x minus 2, and I'm running out of space. I'm going to turn a little bit, x minus 3. Yeah, okay, sorry about that. Ran out of space. So once I find A, I just, sub it back in. So I guess I could be lazy and put it up here where it's a little bigger, but I just would rewrite it. Now, the nice thing is you could check in our decimals. This one, we knew the perfect degree, and we knew the y-intercept, and we knew a lot of details. So this one, if you graph it, it should look right. All right, let's do one more, and then we'll end with this guy. All right, so I have a graph. Again, positive bunny ears, so not reflected. So let's make our function. All right, I have 1, 2, 3 x-intercepts. So let's see, what do I have? This is in -1, so the shift would be positive 1. This is just x, no shift, so that's x. And this is what, 1, 2, so this will be x minus 2. All right, let's look at overall behavior is even, so it has to be like x to the 4th, x to the 6th, x to the 8th, right? Kind of that bunny ears going up, not reflected. So whatever my coefficient is, there's something up here, or some number, I don't know what it is, some constant. But I do know it's going to end up being positive. All right, what's happening here? This is going through, this guy's touching. All right, so at that one, I want an even power. So, maybe it's a 2. I don't have a lot of humps here, so I think I'm okay with that. So let's count. I have 1, 2, 3 changes in direction. Is that right? 1, 2, 3. Okay. So whatever my power is, n minus 1 has to be higher than that. So 4 is the minimum I could have. All right. So let's see, what do I have? If I have x, this would be x squared x. Yep, 4 power, I'm good. Okay. Now, if there's some more humps in here, then like if I added a few more bumps and, ups, valleys, and hills, then this might have to be to the 4th power. Or the odd one, this guy might have to be to the 3rd power. Okay. But I'm solving for A, so it's convenient for me to keep these as small as possible if I can. All right, so then it's like, okay, what am I going to do? Well, you can't sub in these guys because they're going to equal 0. So we're going to sub in an extra point. So here's my output is 4. Don't know what A is. Okay, input is 1. So 1 plus 1, 2 squared, 1 minus 2, -1. I'm just subbing that in. All right, so let's see what I get. 2 times 2 is 4. Times that is a -4. What am I missing here? Oh crap, that should be a -4. All right, actually. All right, I'm just going to keep going. I messed up. All right, this should be a -4. All right, because obviously we're down here, right? So has to have a positive 1, -4. All right, so let's go back. Subbing in the 1 was fine. It's the output that should be a -4. Do you get how I caught my error? It's because I knew this had to have positive behavior, right? So I'm like, what in the heck is going on there? All right, so -4, -4. So, as long as in math, you're going to make mistakes. We just have to catch them, right? So A is a positive 1. So basically what that's saying is, you can write a 1 there, or you could just leave it off, right? You could just say, okay, f of x equals, it's just 1. So we don't always write 1s in math. And there is my function. All right, and this one, again, I could graph our Desmos, see how it behaves, and go from there. Again, if there's more, peaks and valleys, this might be to the 4th power, this might be to the 3rd power to get the right number of, changes in direction. All right, hopefully that helps. I'm going to pause there and stop.